introduction meeting that you have said in the group?
Yeah, so let's just make it more like an introduction and getting know each other about. Let's see what we can do with here. Um, can everybody just introduce ourselves with each other? Hello. We should introduce ourselves. Okay. Can we start? Hello.
Hello, I'm Saurabh Pandey, currently in my third year,
Wait a minute. Wait a minute. Wait a
doing
minute.
engineering.
I think
Okay.
my microphone has some problems. Wait a minute. Hello. Hello.
You can hear me?
Hello. Just
Hello.
give me a minute. Okay.
Hello.
Just it was just few minutes. Okay. I think my headphone is disconnected. Hello. 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 Hello.
Hello.
Yes. Yes. Now I can hear you all. Actually, I won't be able to. Maybe I think my microphone got disconnected. I was not able to hear anyone's voice. Okay. Okay. Let's start introduction and let's start introducing ourselves. Okay. Okay. Who wants to introduce himself first? Yeah.
Everyone. Hello, everyone.
Yes. Yes.
I'm
Yes.
Saurabh Pandey, currently in my third year, B.Tech Engineering.
Okay. That's good. And what are you planning to do next?
Actually, um, I'm just, abhi, I'm preparing for my MS.
Masters.
Yeah.
Yes. I have a small question for you all. Is everyone is here able to understand Hindi? Is
Yes, sir.
any yes is
Yes,
every
yes.
yes is anyone here won't understand Hindi? Yeah. Okay. So Shan is okay, then we understand Hindi. Then I will continue in English. Okay. I have connected. Okay. We can maybe we can start our lecture from here. Okay. Right. Okay. So something with you all guys. Is everyone here familiar with our curriculum? Right. Hello. Hello. Good evening. Just give me a minute. Mhm.
Yes, yes, I am.
Okay, no problem. Let me start first here. Okay, I should introduce myself first here. Okay, okay. First, first of all, my name is Rishikesh Das. I'm an embedded engineer for a few years. Okay, here's my introduction. Who are you? Well, I'm a freelancer working in a field of automotive, industrial, military, medical, and consumer goods. Did I mention I have 3 years of industrial experience? Yes, I do. Yes, I do. So I can tell you that I have like 3 years of industrial experience. So I have quite a lot, maybe not much, but it's freelancing, so it's good enough. So next, specialize in embedded and product development, mostly do bare metal coding. So what I do for my life, okay, what I do for my, what is my actual job is, it's just entirely um, development and producing, like helping other companies build their equipments and products. Okay, okay. Uh, how many projects I was part of? I literally forgot how many it was, but recently I tried to calculate it. It actually surpassed like hundreds, more than 100. Okay, in last like 3 years, I completed more than 100 projects, small and big. In terms of large projects, I had completed like 14 or 15 large projects, uh, which are like I consider to be as quite complex to be exact. And what platform I am proficient in? It's mostly STM32, Novoton ARM, Novoton 8051, and AVR and PIC. I should mention that I did not even touch like AVR for like last more than 1 years actually, not like 2 years, but more than 1 year, simply because of far too many counterfeits and fake parts are coming from China. Okay, next. Okay, what is my educational background? I completed 10, 12 diploma. BTech, I'm dropout actually. I simply don't like their curriculum, so I simply dropped out. But I'm planning to take admission in robotics, which is actually, you could tell it like more advanced form of mechatronics. Okay, so in terms of my educational background, I am not a BTech, but I am a diploma holder in electronics. Okay, electronics in telecommunication. Most important question, why I'm conducting this class here? Okay, this must be some of people got like some kind of confusion or some kind of okay, Amir.
Yes, bro. Actually, I would like to know why you drop out your BTech. So, if you will
Okay,
discuss here, then
okay, that
everybody
is
will get
yes.
feedback.
Okay, actually I had completed my diploma and uh, after like actually I completed my diploma in 2019, after which I took like one more than like 1 years of break due to the corona and directly entered into the industry first. Okay, in which period, after entering my industry, I took like 7 or 8 months of working in industry directly into like R&D. Okay, a company which does like R&D, single circuit. After which I plan to take admission in BTech. I thought that I could like take side by side complete my BTech. Okay, but when you just simply enter the industry, you have like entire perspective that what is actually happening, what is truly is required industry and what technology you are using. And our curriculum is just extremely backwards. It's like completely waste of time. Like what they are teaching in engineering colleges are simply not meant for industry. And even if you are like completed your engineering talk to get like a BTech certificate with the highest possible marks, you are not even suitable for industrial require. You are not even suitable for getting a job in the industry, in true industry. Not even like IITians are not getting a job in our industries right now. Simply why? Our education system and our technical courses are simply
Exactly,
extremely
I'm agree
backward.
with you.
So I thought that it's like completely waste of time. The college people simply told me you have to complete like your 50% of classes. You have to do a lot of things. You have to give like more than like 3 or 4 months entirely to your classes due to exams, practicals, and everything. It was simply a waste of time. It was literally a waste of time. So I just thought that the time I'm wasting getting a BTech, and at that point I actually got like connected with lot of industries which are ready to take me in. Lots of engineers who are completed like their MTech has trained under me. Okay, so company people simply are giving me like a lot of responsibility and they are trusting me. My diploma was enough for them. I simply understand that industry wants skills, not your certificates, and everybody is like uh, just know about it. And after which, like recently, I talked with a small, actually a large company, Bajaj Engineering. Actually, I talked with his like main boss, the person who had made like the main person who had started the company. The company has like more than 400 engineers work under him. And you know what he has told me? Less than 1% of like engineering pass outs are like uh, job worthy. Okay, they know like something about engineer, like truly about engineering, about their technology, what they had completed, the field they had studied in. They simply don't know anything. Okay, and there was like he had told me like, one extra stuff there. That higher the marks that student has got, the lower its technical skills will be, and harder it will be to manage that guy. That was like I don't even I thought that higher marks means that you can simply train that guy. But he had told me that those guys simply don't want to learn and they have like too much arrogance. So they try to not take those guys right now. They try to go for some guys who are like mediocre, who knows a little bit about technical, so they can just train him. So that's kind of like truth bombs actually faced a long time ago, and recently got like little bit more of like bad news that our entire engineering ecosystem is like shit. It's practically a garbage and waste of time, mostly a waste of time. So that's total in nutshell only. Okay. Any other questions?
Oh, thank you. It will be very helpful to those who are here for them to understand the industry's value of practical in industries and a
Yes.
skill manpower needed for the company, right?
Yeah.
No degree, nothing. They don't care about your degrees.
They
They
actually
care
want you
about your
have to like
skill.
a little bit of like a small minimum possible degrees. Like diploma is like more than
Exactly.
enough for them if you know your work. Okay. You just
Because
have
I
to.
was working on a company under me, MTech guy was working, and he was doing that mechanical work like nut bolt tightening and all. So he was like got frustrated, completely frustrated, and left the company.
Hmm.
So yeah, it's just you need to be skilled. He
Hmm.
was gold medalist in I think IIT uh, Kharagpur.
IIT Kharagpur.
Yes, in one project he did with IIT Kharagpur, and in college also he was gold medalist.
Okay.
So I thought that the skill is more matter and practically sounded with practically sounded.
Yes. Yeah, when you like complete your college years out, get out of your campus, you actually start to face like real world, where you actually see like what should I call it? Uh, there are like lots of filters there, true filters which only like to let people pass with like real muscles they have, not like those paper marks and paper certificates. When the real world comes, the everything starts to feel like shit. That's true. True economics. Nobody should wanted to pay you like 80, 90,000 or 1 lakh or 2 lakh rupees a month for doing nothing, just sitting there. Companies will uh, simplify you the first chance they get. Okay, make sure that you have skills. For myself, I just don't want to get into any big corporation and take a job there. I just don't want to get lick people's food there. Okay. Any more questions about me? Yes, Amir.
Yes, exactly. I also want to say, and I also right now focusing for the freshers to get the job in industries. What are the needed in embedded and IoT technology? What advancement they need to be prepared for? So hopefully we will try to bring all those things in groups so they can take the value,
They
more
can upskill
advantages
themselves.
from that. Hopefully with you, and you are doing good job. So keep it up.
Okay. Okay. So, I think that there would be any other questions about myself. What me? Okay. Okay.
Which
Can
is
we?
your first company? And
It was.
what
It
other
was.
skills?
Actually, my first company was a signal circuit, which was like a paid company. Okay. Before that, it was Technoscript, a training institute, which actually took me for like I actually worked there for like 1 or 2 months for like temporary reasons. And just when I got like a chance to like ditch that company, I simply ditched it. That was a training institute, and after which I took the company Signal Circuit. Actually, there was actually a small reason why I actually take that company. I actually want to learn it, and I actually searching for a desperate company which wanted to like take me and teach me everything. So I took a company which was kind of starting to fail because their top employees are leaving them, and company was like not doing extremely well because of that shortage of manpower. So I when I just got there for like an interview, actually search for those small reasons there. When I just see that I can actually exploit it and learn a lot of thing about this company and let them give me the kind of job that I wanted. I just took that opportunity and took that company's job, and actually it paid well, extremely well. They actually put a lot of work on me, which I literally wanted to learn. Okay, development to the supply chain, servicing the equipment, knowing how the industry works, how everything how the actual industry is, and truly speaking, you really want the job which actually helpful for your future. Like for me, it was more or less to learning the entire industry. So I took such company. It was a single service. After which, I simply move on and started my freelancing career, uh, product development, mostly in electronics industry. For the beginning, I actually only worked on microcontrollers, embedded. Now I am actually moved to the entirety of electronics, like power electronics, analog, controllers, the PCB designing, and I also try to help my customers with like supply chains, setting their manufacturing, identifying new opportunities, analyzing their market. I simply do that so I could learn it. Okay, I do lot of work just to learn it. Simply, you can learn the things just by doing it, not by reading it, not by attending a podcast, or just like we are just doing, we are joining a training here. Okay, you just won't able to completely learn STM32 just by sitting here. You have to do it by yourself. You have to do some sort of your own projects. Then only you will learn those skills. Okay, okay. Here, any other questions?
Hello, sir.
Yes, Omkar.
I am also a diploma student. I have completed diploma in electronics
Yes,
and currently pursuing B in VLSI engineering
that's good. That's good.
under this GPIO University.
Hmm.
But sir, I have quite interest in embedded. How can I start? We can, you have no, in diploma we use 805 microcontroller. It is a 8-bit microcontroller. But now in industry, we are used 32-bit, 64-bit, and
64-bit, 32-bit microcontroller. Okay. Yes. Actually, you can learn it just by being connected with the people who are working in it. Are you the part of that WhatsApp group? What was its name? Just a minute, let me search it. Yes, Global Embedded Systems. Are you the part of
yes,
Global
sir.
Embedded Systems? Yes. Then that's the you have already took like a first step there. If you have any kind of questions, just put a message in that group. Someone will always answer. Like I always answer people if I
Yes,
know
sir.
an
Yes, sir.
answer. Okay, and you can just simply start by doing some project, and you can also like put their message that you want to do some projects for free if the other party is willing to like pay you for the just parts. Like you need like IC which are like expensive 400, 500, even go to the like 10,000 rupees for just for the parts. Okay, you can just tell them that you are willing to do some of their projects for free if they are willing to pay for like just parts. Okay, people will simply approach you. Okay.
Yes, sir.
You are from where you are? What is your location right now?
Pune.
Pune. That's good. That's good. You can actually do a lot of. You can literally join with a lot of companies which simply want to like take you in. Okay. You can start building projects for them. Start connecting with the people. Okay, you can also connect with me because I am also from Pune. Okay.
Where are you from, sir?
I am from Chandrapur district. I am right now living in Pune, Birwadi, close to Katraj.
Okay, sir.
Okay. You,
Meet soon.
uh, in which college you are learning right now?
AISMS COE.
Okay. Yes, Mr. MD Kamran Javed. Yes. Actually, I'm planning to come to Bangalore in maybe in like 1 or 2 months, 2 weeks. Actually, I have to go to the Hyderabad for like a small business meeting with a small company. Actually, not a small, actually large company. I'm planning to go come to also Bangalore for attending some expos there. Okay, no problem, Mr. Javed. Yeah, we will. I probably meet with you. Okay. Okay. Any more questions? Okay, no questions. Okay, maybe our introduction with each other maybe has completed right now. Okay. Any questions left for me? Yes. Okay. What is the question, Javed?
Hello, sir.
Yes, Mr. Omkar.
Please, please explain. Means, हाँ सर, कौन कौन से टाइप में एम्बेडेड में जैसे सॉफ्टवेयर है, हार्डवेयर है, सिस्टम डिजाइन है, वैसे कौन कौन से टाइप्स है, प्लीज एक्सप्लेन करेंगे डिटेल में?
अब मैं समझा नहीं कि, मतलब कि एम्बेडेड में कितने टाइप्स होते हैं।
हाँ सर।
एम्बेडेड में ऐसा देखा जाए तो बहुत सारे टाइप्स हैं। हम मोस्टली इसको 8 बिट 32 बिट और 64 बिट में शिफ्ट करते हैं। 16 बिट भी है, उससे नॉर्मली हम लोग इग्नोर करते हैं क्योंकि मैंने आज जैसे मैंने अभी 32 बिट में काम करता हूँ ज़्यादातर और 8 बिट में। मैं 16 बिट माइक्रो से कभी काम नहीं किया। तो ये तीन मेन कैटेगरीज, चार मेन कैटेगरीज है, 8, 16, 32 एंड 64। उसके बाद में जहाँ तक सॉफ्टवेयर की है तो इन डेवलपमेंट इन्वायरमेंट्स ही मोस्टली होते हैं, उसके बाद हमारे टूल से जुड़ी चीज़ें होती है। और एम्बेडेड में देखा जाए तो मोस्टली डिजिटल को ही माना जाता है एम्बेडेड। ओके, अब बहुत सारे डिटेल में तुम्हें बता नहीं सकता क्योंकि उसमें समझेगा नहीं अभी।
और व्हाट इज द सिस्टम डिजाइन?
सिस्टम डिज़ाइन तुम किस तरह से बात कर रहे हो उस पर डिपेंड करता है। अगर तुम सर्वर लेवल में बात करते हो तो फिर तो इंटायरिटी ऑफ स्ट्रक्चर है। अगर तुम एम्बेडेड में बात करते हो तो एम्बेडेड सॉफ्टवेयर में कहने से जैसे आर्टॉस है, तो आर्टॉस खुद भी इंटायरिटी में सिस्टम डिज़ाइन है। अगर तुम हार्ड कोडिंग कर रहे हो तो वो एक सर्टेन लॉजिक की तरह कर रहे हो, जैसे कि कई सारे पार्ट्स, उसमें कई सारे मॉड्यूल्स बना सकते हो खुद के सॉफ्टवेयर के, जो कि काफ़ी इंपॉर्टेंट टास्क का हैंडल करते हैं। कोई भी अगर मॉड्यूल ब्रेक होता है, इंटायर सिस्टम ब्रेक नहीं होता है। ये एक्चुअल फिजिकल में बता रहा हूँ। अगर आर्टॉस, जैसे कि आर्टॉस में तुम्हारा एक भी थ्रेड डैमेज हो जाता है किसी रीजन से, तो इंटायर तुम्हारा आर्टॉस सिस्टम क्रैश नहीं होता। वो भी एक तरह का सिस्टम है। उसके बाद तुम हार्डवेयर में बात करें तो उसमें मल्टीपल सिस्टम्स आते हैं, जैसे कि कुछ सिस्टम एडीसी को संभाल रहे होगे, कुछ सिस्टम डीसी को संभाल रहे होगे, कुछ सिस्टम तुम्हारे मोटर कंट्रोल को संभाल रहे होगे। और अल्टीमेटली सिस्टम डिज़ाइन में सारी चीज़ें सिंक्रोनाइजली काम करती है और सभी चीज़ों को पता रहता है कि क्या कर रहे हैं। ये मैनेज फॉर्मेट ऑफ वर्किंग को ही मोस्टली सिस्टम डिज़ाइन कहते हैं। मैं तुम्हें थ्योरेटिकल में नहीं बता रहा, बल्कि ये एक्चुअल वर्ल्ड और रियलिटी बता रहा हूँ कि कोई भी सिस्टम में आप मल्टीपल मॉडल्स थे जो कि एक दूसरे से इंटरेक्ट कर रहे होता है, बीच में हमेशा एक मास्टर होता है जो कि हर चीज़ को मैनेज कर रहा होता है। समझ गए?
ओके सर।
ओके।
हाँ, समझ गए।
हाँ हाँ, ये थ्योरी से, अगर ये थ्योरेटिकल से थोड़ा अलग रहा होगा, पर रियलिटी में वही होता है। ओके, एनी अदर क्वेश्चंस? Okay, no questions. Okay, let's get to our curriculum first. Okay, let me check out with my curriculum here. Just give me a minute. Okay, there's our curriculum. Put it on the screen first, okay? Sharing. And, okay. Just give me a minute. Perhaps. Wait a minute. Mm, okay. Here is our curriculum. Can everybody see able to see our curriculum here? Hello. Is everybody able to see our curriculum? Just
Yes.
answer. Yes. That good. That good. Okay. Uh, this STM32 course is going to be based on bare metal programming. We are not going to use any kind of libraries like we actually able to see in Arduino and ESP32. We are directly going to use register level programming most of the time. Okay. Sometimes we are going to use pre-built code like for clock configuration. It simply is too hard and it requires its own entire course. Okay. Okay. The board is used STM32F401C2 black fill. If you are planning to plan to copy this course on like physical hardware, you should go for like a black fill F401. Okay. And what about the fees of this course? It's free. It's entirely free. Okay. I'm not going to take you a single penny from you or a single rupiah, so you don't have to worry about anything cost. But you need to buy your hardware. Okay. Uh, Frequent tasks are going to be reading datasheet and debugging. Okay. We are for the entirety of course we are just going to look for the like datasheets a lot because that's the kind of document you should be referring when you actually get any kind of IC or any parts, like not even like a microcontroller or like electronic parts. Even when you get some kind of like simple part like this kind of alcohol, cleaning alcohol, you should check its data sheet and information that what it actually is, what kind of corrosive materials it is, and where it is, where the manufacturer recommended to use it. Okay, even sometimes if you like put alcohol in some kind of alcohol is not good for certain materials. Okay, not every alcohol can go to like every material. Okay, you could ruin everything. Okay, uh, we are going to use hardware and simulation side by side. Software, we are going to use our STM32 Cube IDE and Proteus. For programming and coding purposes, we are going to use STM32 Cube IDE. It is provided by the ST Microelectronics, and Proteus is a simulation software. It can also do like schematic and PCB designing, but we are only going to use it Spice and uh, microcontroller simulation. Okay, let's get into what our course is going to be. Okay, first will be introduction to the STM32 F401 using datasheet and introduction to reading datasheet. Okay, we have it is like self-explanatory what we are going to do. Then second we are going to do is introduction to the GPIO and RCC. There will be like multiple projects, linking entity, some segment display, input button interfacing, student project. The student project is quite peculiar here. The students have to choose their own project and I am going to assist them to complete it. Okay. I am going to assist you to complete your project. I will be your assistant there. Okay. There will be some extra projects in GPIO section. 16-bit LCD interfacing, 8-bit, 16 to 4 LCD interfacing, 8-bit and 4-bit. Matrix button. Actually, I should call it button scanning or something else. Then there will be another student project. Then there will be introduction to timer. I should look in there like timers. Timer is good. There will be like multiple projects, LED blinking, timer interrupt, 7 segment display scanning. This will be a extremely good example for like what truly like industrial programming looks like. Okay, I try my best to show you how you should program your software or firmware in such a way that it will be extremely like effective, efficient, and like usable and readable. I will try my best to show you. Okay. Then there will be another student project, and then there is the extremely good part, which is like most used peripheral in any microcontroller or in entirety of embedded is ADC, introduction to ADC, reading 12-bit ADC data. And I'm also going to show you how you can like calibrate it, how you could like simply read like binary data and convert it into like some relevant data like you have like voltage or temperature readings. Okay, you after this you can simply interface lots of sensors like voltage, current, and they will like temperature, humidity, and lots of whatever sensor gives the output analog. Okay, display data in segment display, and there will be a student project, and there will be like our first communication protocol, USART or UART protocol. It's quite it's actually an old protocol, but we need to learn because it's still used in a lot of places, and we simply call it with other names like IS232. Some people like to call it like lots of name, but it's underlined it's like a UART. It comes with like dozens of different names, so it's kind of a must right now. It's extremely old. And there is like some big boss protocols like I2C communication. We are going to do a small project like connecting our external EEPROM IC. In our STM32s, we simply don't get an internal EEPROM. Okay, when you like need to store some of your data in some memory device, you can go for like using its flash memory, which is like not though does not have like too much of a read and write life. You could simply damage it if in long-term use, and you simply can't even replace like the main core microcontroller. You need to opt for like external memory. External EEPROM seems to be right. There are like lots of other communication, like other external memory options. There are like NAND flash, and there is like FRAM, which is like super good for like high frequency data storage and high frequency changing data storage too. And there will be like high power protocol, high power communication protocol, serial peripheral interface (SPI). We are just going to do like one project there, like sending data. Also going to include like receiving data too, and there will be also a student project. Okay, every section has one student project here, so I'm actually going to assist you to complete that project. And at the end, I probably, if you guys are interested, I'm actually try to introduce you to DMA, but we are not going to do any like some serious programming for it. But DMA is like extremely high power. You should maybe not call it like peripheral because it itself is a master, so more like a processor with lots of handicaps, but it's extremely powerful. It actually helps you to achieve maximum potential of your microcontroller and all the peripherals. In datasheet, you are going to see that certain peripherals have extremely high speed, but you won't able to achieve it. Simply why? Because your processor and timing and core processing time is just too high. To achieve a maximum potential of your device, you need to use DMA. Okay, but we are not going to learn it here. But I have provided some information about the DMA. It's extremely important. It's available in like all the new microcontrollers, microprocessor, and SoCs. Nearly all modern ones. Okay, I provided some of my social media links, my email, my personal number, which I shouldn't be like providing, and my LinkedIn profile. Okay, okay. Now, any questions? Hello, any questions?
No,
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 sir.
no. No, sir.
No questions.
No, sir.
I should say you that I truly love the questions here. Okay, so don't be like uh, reluctant to ask any. If you want to be answer of your all doubts, you need to ask questions. In my last session, after the completion of my like this class, people literally just messaged me and called me up regarding their questions. I simply told them that if you simply don't ask the questions, you won't get the answers. I will really love that you simply ask a lot of questions. Okay, okay, and please just can someone start their cameras here? Okay, please, I will love to. Just start it, man. Okay, we should immediately get into like data sheet stuff. I'm actually directly sharing my entire screen. Wait a minute. With me. Yes. Can you guys see my browser screen here?
Yes.
Yes, you can see it. Okay. Can anybody tell me what is the manufacturer's name of the STM32 microcontroller? Can anybody say? Can anybody tell me the name of the STM32 microcontroller? It is ST Microelectronics. Okay. To get the data sheet for any of the parts you are working with, you should go to the its manufacturer's website. They give like the best possible uh, like a data sheet and all the study material for that for their part. Okay, that is just load a little bit. Okay, you simply have. Can anybody just tell me what part we are using? What STM32 we are using? F401CC. We are just searching the part number. Okay, what can you see here? Hello,
Product,
what are you able to see here? Can anybody tell me?
product.
Product, yes, that product. Specifically, one of their part STM32 F401 CC. Okay, let's see what we are dealing with here. Just at the pages, maybe it had like headline, I should say, by header. We can see some of the information about this specific microcontroller. It's a high performance access line. Okay, ARM Cortex M4. It has ARM Cortex M4 core, or should I say processor, with DSP, digital signal processing, and FPU, floating point computational unit. Okay, it has 256 kbs of flash. Just let me join us one more person here. Okay, just give me a minute. Yeah, 256 kbs of flash, and it runs at 84 megahertz CPU, and it also has its internal art accelerator. It's actually a graphics processor. It's internal. Uh, can you see that? We have graphics processor in like a dedicated graphics processor inside a microcontroller itself. You can literally attach a display with it, like a mobile like display, and make a mobile like graphical user interface for yourself. I wanted to join, but I won't able to see that. Okay, okay, that's just first done. Whenever you are actually searching for a data sheet, there is like a two main documents there. One is a data sheet, and another one is like a reference manual. So let's just download a data sheet first. Okay, so let's download it. And here is like some more deep information about this that part we are talking about. To know this. Okay, some more
Hello, sir.
overview of our part with lots of other information to select which in the right part here. You can select all
Hello,
the
sir.
yes, yes, yes.
Sir, what's the meaning of ARM Cortex? Like,
The ARM is actually the main company which like designs the processor.
particularly Cortex, what's the meaning?
It's more or less like a branding itself only.
Okay, okay, okay,
There's no meaning behind like Cortex. And
okay.
about the M4, it's like a line of like i7 processor, like Intel i7,
Yeah, yeah,
i5,
I know that.
i3, that kind of.
Yeah.
but the number itself means a lot. Like M0, M4 is like significantly more powerful than M0. But with what terms you should know about it? Like in mostly M4, you get like internal floating computational unit and also digital signal processing. But in M0 you don't. What's the main difference? It is accuracy and speed. It simply has just far too many instruction registers to get the things done. You can do a lot of complex instruction in just a single cycle, but M0 will take like a far too many instructions to complete your single command or to complete a single process. Okay? That's like a kind of a major difference here. In terms of all the microcontroller codes, they are like a bare bone itself. They don't have like far too many like instruction registers. They have like enough more than enough to like satisfy our requirements and nearly most of our requirements. Now even
Okay, sir. Okay, yeah.
what we are doing here right now, what I'm going to teach you, it all that can be done with like M0. Okay, and most of the industries work can be done with like M0 processor. M0 itself is like far too powerful than any 8-bit and even 16-bit microcontroller, significantly more powerful than any 8-bit and 16-bit microcontroller. Okay, so just don't worry about it.
Okay, sir. Okay.
Okay, okay, we can like get like lot of other information here. Like, it has like USB and other stuff. You should like read it to first like selecting your part whenever you are trying to. Here's like a block diagram of that microcontroller we are working with. It has 16 channel TMA, direct memory access, a lot of other information. Just make it like prettier and easy to work with and find out what you are searching for easier. Okay, all the parts, and it's like mostly basic. Let's go to document and download our reference manual. Okay. There's like a significant difference between like a reference manual and a data sheet. Data sheet nowadays only gives information like briefly and mostly information around like selecting a part and some little bit more in-depth information for selecting that part. But a reference manual provides you information to like program it. Okay, program it or if you wanted to like place it somewhere. I just don't able to find my reference manual. Programming manual. Okay, programming manual is okay. Here's the reference manual. Okay. The programming manual and reference manual is like different. Okay, so okay, we already found our reference manual or programming manual. Let me share my screen with you. Stop sharing. Let's share my entire. Okay, is everybody able to see my entire screen here first?
Yes.
Yes. Just
Yes, sir.
let's first open like our data sheet here. Here open our data sheet. Okay, just let me move all this. Stop sharing. Okay. Okay, now we are actually seeing our STM32 data sheet. It's mostly a brief information about your microcontroller. It's not like a for you. It's not like brief, but for the programmer work with your part, all the information you need is not actually here. It actually gives information on like block diagram, and it's actually extremely useful, but not good enough for like programming. Okay, okay. So what kind of information we are getting here? As I told you, it is actually quite useful for selecting your part. In its very first page, it has given like all the information you need to like quantify what its actual power is. It has a M4 32-bit MCU with internal FPU 105 DMIPS per second. Then there is a 256 KB flash, 64K RAM, 11 timers, 1 ADC, 11 common interface like communication interface, 11 different. And also it has given the information on what parts this part is available, what packaging. There is like a QFN package, BGA, it's like a different wafer level package. Then there is a ball grid array package and QFP package. You can see like a little bit longer information. It's like a more of like a dimension, but in terms of footprint, it's like a QFN wafer level package and BGA and QFN. QFP package. Okay, and also given how many pins there this package is 100, 149 and 48. We are dealing with here is the QFP package. In like black pill, we actually get this one UFQ, FP and 48. Okay, quite a mouthful there. It comes with a 48 pin and its dimensions are 7 by 7 mm. It's small, okay. 7 by 7 mm is small. And here you can see the vapor level package is size is 2.965 mm by 2.965 mm. Okay, it's like extremely small package. If you like drop it from like your table to ground, you simply need to forget that you ever going to get it. Okay, we have like a little bit more briefing here about our microcontroller. You should like read it. I have a question for you. Should I like explain this first page of this my like data sheet? It's actually important. Should I like explain to you too what it is?
Yes, sir. Yes.
Okay, I should like explain it. Okay, first here dynamic efficiency line with VAM batch acquisition mode. Okay, what it is? Okay, you should maybe you don't require it too much, but first you have to see what is its voltage levels it operating. It works in 1.7 volt to 3.6 volts. You have to provide it power supply of between 1.7 to 3.6 volt to operate it. If you go below it, it will cause then what should I call it? Blackout. There is like a one specific word for it that ICHE stops working. Brownout detection or brownout system. Okay, SWIC goes a little bit lower, but below 1.7 it won't work, and above 3.6 you are risking damaging the entire microcontroller. Okay, there's the first information, and here are four. It is an ARM 32-bit Cortex M4 CPU with FPU. All the information I have previously told you. Okay, about the memory. Okay, it has a 512-bit OTP, one-time programmable memory. You can put like your license, your information, your keys in there to like tell it that this is your ID number and this is what it actually saves like manufacturing from counterfeiting and other stuff. Then there is information about clock reset and supplier management. All the information you need here. And again, power consumption. It's actually quite tricky part. Can anybody tell me what they had actually like written here? Okay. Can anybody just tell me what actually written here? Read it out loud, please. Hello, please just read it.
It's 128 microampere slash megahertz peripheral off.
If all the peripherals are off, okay, it is actually its power consumption per megahertz. Well, it consumes that much of current per megahertz when all the peripherals are off. Okay, all the peripherals are off means that its processor consumes that much of power per megahertz when all the peripherals are off. If you want to like calculate the power consumption of a microcontroller, you simply can't do it like extremely accurately. You never able to do it. You need to like when you want to like go to like power saving mode or anything, you need to like completely turn off your entire peripherals, even your processor, like complete deep sleep. Okay, then only it is like good enough to power thing. Actually, the newer microcontrollers have such a facility that your microcontroller will never need to come out of your sleep to get its like acquisition of external data from ADCs and others. Its internal DMA and whatever the peripheral you are planning to use, like its external ADC, maybe with some low power timer, you can do it like for like entirety of life to data acquisition of its entire data. Okay, without never even needing to wake up its processor. If something really gets goes wrong, then only maybe it needs to get its processor turn on. Okay, and there are like other information like temperature and how should you use it, what are these parameters that should be used. There are information that here it has 1 into 12 bit 2.4 mega samples per second ADC. You will never able to take good entire benefit of like this 2.4 megahertz sampling rate by using like normal coding. You have to use DMA to take advantage of like this entire sampling speed. Okay, you're never able to use it with just processor based programming. You have to use like DMA to take entire advantage of it. You got like up to 11 timers. It has like 16 bit and two 32-bit timers. Some people has told me in the past that a 16-bit is not large enough. Okay, 16-bit is large. It's like more than enough for like more near like all the processors you need. It has its own 16-bit or even sometimes 32-bit prescaler. So it's like good enough large for me. But you can go for like higher frequency and higher clock rates for like getting a significantly more high precision. So in that case, you can use like 32-bit counter something. Okay, let's again. Here are some packages here again. Then there is a debug mode. The most important thing you should always look when you are selecting a microcontroller. You always should select a microcontroller with a debugging interface. It's extremely crucial. It's important. It's like a water and food for you. You just can't live without it. Okay, it should have its own dedicated debugging interface. It must. Okay, those serial debugging and others like shit you mostly like people do with ESP. Sometimes people work with like Arduino or do like serial interfacing. That's practically a garbage. You never able to get like all the information you need. Okay, how your code is actually behaving, you simply can't get it. Okay, you are always scratching your head. You never able to make your system super clean, work fluently, never able to. And next, up to 81 IO, okay, IO ports with interrupt capability, okay, or IO ports are 5-volt tolerance. What it means? If you put a 5-volt voltage along this microcontroller pins, it won't get break. But in some microcontrollers, some pins are 5-volt tolerant and some are not. So always check out what you are working with. Okay. Okay. 11 communication. You got a 3 I2Cs, 3 UART with like okay I2C with like 1 megabits per samples per second. You also got Modbus and PM bus, SM bus and PM bus, and up to 3 USART with like 10.5 megahertz. Do you think you ever be able to use that much of high frequency with just its processor? Never. You need to use like its internal DMA to get that much of speed. And there is also like SPI with comes with 42 megahertz. You will never be able to use that much speed just with no normal coding. You need to use DMA for it. Okay. There is like a serial data IO, and there comes a big heavyweight communication protocol USB 2.0. Okay, it has its own unique 96-bit unique ID, and it has its own internal real-time clock. That's like it is like a complete package unit. But nowadays, lots of microcontroller with comes with like mostly same kind of package with extremely low amount of cost. Actually extremely cheap because a lot of times you simply don't need like 3 I2C, 3 SPI, 3 UART, and such a powerful combination like a GPIO, sometimes EPDSI, internal graphic processor. You simply don't need such a high power like peripherals. So, and in most of the projects you simply don't use such peripherals too much. Okay, one SPI, one I2C is like, in most of the project, one I2C and one SPI is like more than enough. Mostly people need is like too much, far too many pins, and sometimes maybe like do some communication with computer and simple tasks. So, only in few unique cases you are going to need so many of like peripherals and other interfaces. Okay, any questions, please? Hello, any questions? Is everybody awake or not?
No, sir, continue.
Continue. No questions? Please, I would like to have some questions here, okay? I will love to. Okay, I see there is no question yet. Wait a minute. Hmm. Okay, okay. Then where we should start? Okay, okay. Uh, yeah, we can directly go to like microcontroller block diagram first. Yeah. Can anybody tell me what you are seeing here?
Architecture, huh?
Yeah, it's you simply can't call it architecture. Okay. Yeah, you should me. It's on you what you want to call it, but it's mostly give like overall information that what this microcontroller offers and what communication lines it is using. Okay. When you become experienced enough, this single block diagram or your architecture gives you more information, uh, enough information to like simply code it or make it like more efficient. Okay, it has good enough information to know that what peripherals are directly communicating with processor easily, like which DMA can operate with which peripherals. You can simply see that lines are going from one place to another, simply showing that how they are actually connected with each other. Okay. Some experienced programmers don't even no longer require to use like a reference manual for programming. They simply open this block diagram and their pin mapping file or a pin mapping table to program the entire system for themselves. They don't even like bother to like open the reference manual. Okay, all the information is simply neatly provided here, like which timer is connected to which data lines, huh? And you can simply see that how your processor is connected with your AHB matrix and how it is communicating with all its peripherals. Okay. With time, you will start to learn that how can you use this neat block diagrams or whatever you want to call it to maximize your productivity. Okay. Okay. Now, second one is this. This seems like not so much of an good block diagram, right? But it's like super important. Can anybody tell me what it is? Can anybody tell me what it is? This single diagram or this single, like whatever you want to call it, like image, gives you more than enough information that what are your access line and what kind of privileges that every single peripheral and component has. You can directly see that your ARM Cortex, your main processor, has like highest possible privileges. It can literally access everything here. But your other master, like this one, this upper side blocks and upper side peripherals or devices are actually the bus masters. This right side devices are actually all the slave and peripheral parts. Okay, you can see that the DMA and other information and how they can access each other. It could be like super useful when you are programming and you simply know that how to maximize your speed. Okay, this is like super important. Another information about DMA, maybe our uh, like for okay. Remaining things I'm going to actually going to teach you during our uh, lectures, our future lectures. It should be like more than enough for you guys. I just don't want to like overwhelm you. Okay. Uh, now Is there any questions or should we start to our first coding? Okay, what is the port? We can go for like our academic like description, or should I tell you what my views on the course are? In terms of academic description, these are the peripherals or the paths processor has to communicate with the outside world or outside devices. It mostly consists of a general purpose input output, but it is also the path for internal peripherals like communication devices to access external devices. Okay, this is like academic stuff, simple. But in terms of code, um, they are actually far more than that. Okay, uh, actually they are in nowadays we simply don't use like the words like ports. They are like old generation stuff. Now we have like general purpose input outputs and uh, peripherals which can directly access external world with far too much autonomy itself. So nowadays ports are not that much of a relevant stuff, but still we use this terminology to like make sense of things. Okay. Okay. Any other questions, Javed? Any other questions? Some part details. Can you explain it another a little bit more? Part details. GPIO segment. Yeah, GPIOs. LEDs. Yeah, I'm actually going to uh, make a practical out of it. Actually, it is a part of our project here. We are actually going to access our so-called ports. Yes, we are going to do like basics. Actually, this is a GP, this is a register level, so we are going to the basics of the basics. Okay. Okay. Uh, did everyone actually already install their software like ST Microelectronics, STM32 ID, and Proteus? Can please everyone simply message me that they all did it? Okay, two people had did it, and remaining of you guys, yes, 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 Javed. Okay, you didn't do it. Okay, yes, you all did it. Okay, I'm pretty sure that you everyone had already did it, and I'm not going to show you how to install it. You need to learn it by yourself how to do it. Okay, you need to install it by yourself. I'm not going to teach you that. Okay, this is not like a what should I call it? नर्सरी नहीं है रे बाबा कि सब कुछ सीखा होगा ठीक है कंप्यूटर का बटन चालू करके चालू बंद करते वो नहीं सिखाने वाला हमें समझे तुम सबको खुद से करना पड़ेगा ओके let me just this off and let me just show you the entire screen. Okay, okay, you can see my entire screen right now. Yes, yes, yes.
Yes, sir.
Okay, we are just going to start our STM Microelectronics IDE, STM32 Cube IDE. Okay, there is like a two different people say that there is like two different IDEs, STM32 Cube MX and STM32 Cube IDE. But in STM32 Cube IDE, you get like all its packages at the same place. Okay, you get Cube MX, Cube MX IDE, even its AI platform too. Okay, so you literally get like everything you need. Okay. Okay, this is like our previous project. Okay. So we're going to like remove it from here. Uh, let's just make our first project new. Okay. Okay. Actually, it's going to take a little while. Okay. While it is just getting itself done, we can have like few more questions here. Do anyone have some questions? Hello. No, sir. Okay. Okay. We simply have to enter like our commercial part number here first. STM32 401 C. What we are dealing with. Just let me see one more thing first. U6 T. We're dealing with this part. Let's give it a pretty name. GPIO. This ID actually launching now our STM32 CubeMX, which is actually code configurator tool, but we are only going to use it for initializing our clock. Okay, we do most of our coding with the help of bare metal. Okay, but we are actually going to use its supporting libraries and all its definitions. We are not like top level freaks here. Like would like to like code like 0x0000 equal to this is information. We are not going to do that here or make our own description library. So I'm not an insane guy, and I know that you guys will simply get won't able to get what we are doing here. It's just taking forever to load up. Can we have a little bit of chat here? I'm getting bored. And please, can someone start their camera, please? Hello, someone's there? Knock knock. Yeah, please turn on your cameras, please. No webcam. Sumit, at least you have started it. Okay. हेलो सुमित राजेंद्र जी को थोड़ा सा कॉल मार तो
क्या?
राजेंद्र जी को थोड़ा सा कॉल मार
हाँ, एक मिनट।
उनको बता कि ज्वाइन करे करके ठीक है
हाँ,
ओके आई थिंक दैट it's just taking forever to start. Okay. uh, okay, is everybody able to see our package here? Yeah, I think everybody able to see it. I will appreciate if you simply like turn on your microphone and tell me something. Okay. Okay. We are actually not gonna use it, but we can simply like set our pins what we want to have it. Like it's alternate functions like I2C, SPI. Maybe put like a GPIO input and output one, maybe analog. We put it for like external interrupt or something else. But we are not going to do it. Okay, we will simply configure our clock. As you can see, clock is in like 16 megahertz right now. I simply want it to be like maximum possible frequency, maximum possible frequency. So you simply put like 42 here and put like 84 here and let this QMX decide how can you do it. No solution found. How can you do find? Searching solutions, please wait. Let it do its magic. Okay.
हेलो सर।
Yes.
सर मेरा वाईफाई डिस्कनेक्ट हो गया था, वो चल नहीं रहा था। 10 मिनट में पिछले क्या हुआ मुझे बता सकते हैं क्या?
मैं तुम्हें सही बताऊं 10 मिनट के अंदर कुछ भी नहीं हुआ है। सही में कुछ भी नहीं हुआ है, तो फिक्र मत करो। हेलो सर जी। Okay. Clock configurator. Okay. As you can see that all the clocks are set. All this clock configuration is already done. You can see that we have like 84 megahertz of clock here. Our processor is getting like 84 megahertz, and other peripherals are getting like 42 megahertz. Okay, we have already done our clock configuration. Let's just build our code here. Just by clicking this upper icon, you maybe won't able to see it right now. Yeah. But just by clicking it, you can start. Okay. Yes. Okay. Okay. As you can see that the Kubernetes has built us a small, neat main file and all uh, other required files here, all the necessary files. Uh, okay. And you can see there are like lots of other header files and permissions provided, but we won't go there right now. Okay, just we can start our first project, our first sample project for you. This is what we can just initialization. Okay. Can anybody tell me what was our first project is going to be of GPIO GPIO project? What was its full name was? Can anybody please tell me? Okay, nobody's telling me. It was GPIO and RCC. Okay, because we have to use RCC. Let's just put a small code here first. RCC H1 no. Okay. No, I should not do it like this. Okay. And there is a GPIO. So one set of output. Okay, we have made our first blinking code here, blinking project. So only our
What is the RCC, sir?
I'm actually going to tell you what it is. It's actually a very important part of modern microcontroller. You will find uh, in every microcontroller, in every 32-bit microcontroller, you will find the RCC. I'm actually going to tell you what it is. Okay, just let me first build this project and show you how it is working. Okay, I'm actually going to tell you. Okay, let it build and let's start our Proteus first. Okay. The kind of produce I'm actually recommended to use was is a pirated one. So you have, for starting this one like properly, you have to run it as a administrator. Okay. If you like directly start it, it won't work. Okay. Okay. Let's just build a small project. Okay, we have built it up. Can anybody just tell me what microcontroller we are using right now? Hello,
STM32 if RC.
F401CC. And we have a part, simulated part here. Just simply going to select it. I need a LED here. LED. But which one should I take? What color of LED should I choose? Pink, purple, red, white, yellow. Which one?
Blue.
Blue. Where is the blue one? Uh,
Hello, sir.
where is the blue one?
Where we can get microcontroller?
What?
How how can pick a microcontroller?
How can we pick a microcontroller? First, in this new win. Okay, let me just show you again how can you pick your microcontroller in this Proteus. Simply say, first you have to select
Yes,
this
sir. Repeat.
small op-amp circuit, op-amp icon. Then just go to like the small this there is like a small P here. Can anyone see my mouse here? I should like make my mouse size a little bit larger.
Yes, sir.
Yes. Click on it P, and in this new window in upper left corner you can see a keyword tab. Just there type your part number STM32 F401CC. Okay. You simply find your part there.
Yes, sir. Yes,
Just
sir.
select
Got
it,
it.
double click it, and so you will simply select it. Okay. Okay. Now just get a LED first. Okay. We got like a lot of LEDs here, but we need a simulated one. Okay. Okay. We have a blue one. Let's just select it. Let's select our resistor. Not a single S. So we have actually got a resistor too. Okay. We have selected all of our parts. Let's place them here. Okay. Resistor here. Place an LED. And place a ground. Actually, today I actually broke my mouse, so it is like a little bit hard for me to like, handle this software right now properly. 20 ohms. Okay, we also need to like this negative DC resistor of positive supply. This is a small supply here. Then we will simply double tap on the microcontroller to get it in the first window. There is a small tab called a program file. You just need to open it and navigate to your hex file. Okay, just let me navigate to the hex file first. Project, my project, training, go to online, documents, 8 minutes, not documents, workspace. Okay, GPIO. Uh, okay, there actually we got only like L file here. I'm not actually going to set like L file. Actually like to build an hex here. 2 minutes. Go to builds. Okay. In by default, STM32 cube only like produces L file. It is like a debug file. You need to like set it specifically like you need an hex file to be built. Okay, build it. Just go to like directory. Uh, what's build? Okay. You have to simply click like I.hex. It is Intel hex. Just click it, and you can also like set up a binary one. Both are like kind of a same. Hex one is like more of a well accepted kind. Apply and close. Okay, let's rebuild our code here. Okay, it will be building itself. I just select go to projects, projects, STM32 workspace, debug. Okay, now you can see that we have like a dot hex file here. Let's just check it, and you can simply see that. Can everybody see that L file is 758 KB and hex file is 14 KB here? Hello, can you guys see that?
Yes, sir.
Yeah, that's right. Let's just select hex file here, and let's see what this thing is. Our LED is it's glowing or not. Okay, see. Yeah, yes. Can you see that our LED is blinking here? That blue light is like turning black and purple. Can everybody see that?
Yes, sir.
Yes,
Yes,
sir.
sir.
Yes. So we had made a like our first code here to blink an LED. It's like a first code in every project, every microcontroller curriculum has. It is also like a testing to see that all of our like tool chains are working properly or not. Okay.
Sir,
Yes. Yes.
can you share a screenshot with our group?
What? I should share my code with you. All right.
No, no, diagram.
Hello. I simply won't able to hear you properly.
Can you share a screenshot of diagram?
Diagram. Uh,
Yes.
actually, at the end of our this class, you won't be needing to like see this diagram, okay? But I'm actually going to do it. Just let me take a small screenshot of it. Just a minute. This is getting a
Hello,
little bit
sir.
hard. Yes.
We cannot provide ground to the IC. How can it
Uh,
work?
actually, in this simulated model, you simply don't need to. Okay. In this simulated model, you don't need to like provide a ground pin to it. But in like a real world, you always need to. Okay. Yeah, just let
And
me
sir,
connect.
VCC, how many VCC would provide and which
In
pin?
actually in a real microcontroller, a real practical real physical microcontroller, there is maybe like maybe like a four, maybe eight pins are dedicated to like a power supply, like positive, negative. Okay, like a real microcontroller. We can simply go and check out it right now. Okay, just give me a minute. Okay, here. Uh, Now we have to see that what package we are using. We are using like QFN package. Is it a QF? Yes. Okay. This is the package we are using. We can simply look at here what pins we are using. What pins we are have available and what for the port. VDD and VSS. Okay. VDD is positive. VSS is negative ground. Okay. 36, 35, 1, 2, uh, 1, 2, 4, pins, 4, 5, 6. Okay. There are six power pins here. Okay, 48, 47, 36, 35, and 32, 34. These all are its power pin. They are battery pin. This is a negative reset pin. Okay, and all lots of pins they are there. External. They have this dedicated pin for like external external crystal in the reference and all other things. Okay. Is I completed your is I able to fulfill your doubt? Hello. Is I able to clarify your doubt here? Please answer.
Yes, sir.
Okay. Okay. For such questions like what are its physical pins and everything, you should always go and check out, always refer to its data sheet, okay? For all its physical parameters, okay? And you should know that what package you are using, working on right now, okay? Actually, I had given you answer for this black pill microcontroller, black pill development board. It uses this package on this microcontroller, okay? So where are we? Okay, we had completed our this first LED blinking demonstration. Let me just show you how actually I've done it. For which we, for to know what code I had written here, we actually have to refer to our reference manual. Okay, let's go to our reference manual, which we had downloaded here. This larger size PDF is our reference manual. Let's open it first. Okay, we are at our reference manual. Let's see what code we have written here. First, we had uh, used a RCC block and its AHB1 ENR register. Okay, this register block of RCC and the specific register we had used inside it was AHB1 ENR. Okay, this registers we had put like one in like first bit of it, first bit. Okay, let's see what actually is the RCC. Okay, in its first it says what it is. Can anybody please read it out for me? It's like heading 6. Can please somebody please read it out for me, please? Okay, nobody is going to read it out for me. I have to do everything by myself. Okay, reset and clock control. Okay, what is a reset and clock control? At the beginning, I had told you that you in modern microcontrollers uh, all its peripherals are like power down, all its clock is stopped. On it does not have like every peripheral is does not getting like a power and it's not active. Okay, for like power saving purposes. It's also the same thing. Uh, for each peripheral, we had seen in the block diagram and I had described in our lecture here. It for activating it, you first have to activate it through the RCC register. RCC actually is like a compound word for like a block of register to start and stop a clock for every peripheral it has. Okay, let's just see what we had done here. Let's just go to the RCC block diagram first. As we can see in the left hand side of our PDF, we have got like lots of RCC registers here. Okay, RCC control, so everything we need. Okay, got lot of, but most important one was HB1 ENR. Let's see. Can anybody tell me what you see here? Please, please, just tell me what you see here. Hello, anybody home? Hello, 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 hello. Okay, nobody is saying anything.
Register.
Yes, there are a lot of registers. One can specifically tell me what is the zero bit of this register says. I can like zoom it out for you.
It's like diagram.
Okay, can anybody tell me the zero bit of this register is what it says? Zero bit. It is zeroth position, like specifically at its right hand side corner where I am like waving my mouse right now. Anybody tell?
GPIO enable.
Yes, bullseye. Enable your GPIO port. Okay, I'm calling it a GPIO port, general purpose input output. To enable it, you need to put one in this zeroth position of the RCC register. Okay, it's like a ASB1 ANR register to start that GPIO port. Without putting like a one in this port, you not even able to like change its register bits. Okay, you simply can't do anything with that. First, you have to activate it. To start the STM32's microcontroller, STM32's certain peripheral. For like entirety of its peripherals, you have to perform this task always to start it initialization process. This is the bare minimum you have to do. Okay. Second, what we had done next, we directly go to the GPIO A registers moder. Okay, it's the mode register. Let's see what we had done here. Let's go to the GPIO A register. Okay, where is GPIO? Yes, where is GPIO? Okay, can anybody tell me what I had? Okay, GPIO register to set any single pin, you have to manipulate two bits of a register. Okay, as you can see there, motor 0 is controlling the pin 0. Okay, 0 1. Okay, no, it's not like that. Okay, motor 0 is representing uh, pin 0, PA0 pin. Okay, just like that, motor 1 representing a PA 1 bit. Okay, to set what configuration you want your GPIO pin to be. Can anybody tell me what modes GPIO pin can be in? What modes there are? Can please somebody tell me? Okay, I need information. I just don't know what modes pin can be in. Okay, please can somebody tell me what modes GPIO pin can be in? Yes, Mr. MD Javed. Yes, tell us. Hello, just tell me what modes could be in. Okay, nobody's telling anything. Don't know. Don't know. Okay, the most bare minimum is the input and output. Okay, there are a few more like in analog mode or in a alternate function mode. Okay, in advanced microcontroller there are alternate function mode. It is the mode for like SPI, UART or any other peripherals which communication lines are going through those certain pins. Okay, so we are saying here that for putting this GPIO in output mode, we have to put like 0 1 in its model register, 0 and 1, which I had done here also. Okay, I put 0 1 here, and there is like a GPIO output data register. I simply put like 0 x 1 and 2 uh, put a lower value there. Actually put 0x 0 there. Okay. It was extremely simple to do it. Okay. To blink the LED. Let's go to the GPIO output data register to see what its structure looks like. There are actually like quite a lot of data registers are there. You can see that it's actually a 16-bit register, 0 to 15 means 16 bit, and remaining 15 bit, remaining 16 bits are simply not used, and you simply can't use it. So every bit representing a one, every bit is representing one pin of this port, GPIO A to GPIO H. Okay, if you put one in a specific bit, like if we get a 8, it will turn on like a bit pin 8 to high and 0 for low. And to read the data from the pin, you have to refer to the input data register. We are going to use it when we are going to use like a external button interfacing. We are actually going to use it. Okay. Any questions? Please, questions, please. Hello, Rajendra sir. Any questions, please? Anyone has some doubts? No, sir. Okay, no doubts. Okay, it seems like people have few doubts there. Not everyone is sharing facts. Hello, Mr. Amir Khan, sir. Do you have anything to say? Mm, okay, that is how we actually manipulate a single bit in our microcontroller and how we actually control our GPIOs. I'm pretty sure our um, class is over by now. If somebody really okay, let me just do a little bit more for you. Let me show you what is our entirety of GPIO is. Actually, in every GPIO, we get it is not only in like input and output mode. Its input and output also have certain characteristics. In ARM in STM32, we are using we got quite few more features we can use like internal pull up and pull down resistors. We can put our GPIO outputs in like push pull mode and open drain mode uh, for certain behavior we want to achieve. Okay, they are like output speed register, which help us to like mitigate external EMC, EMI. We most of the time we simply don't need it to be like in extremely high speed switching. Even by just going like slow speed is good enough for us. There is like pull up, pull down resistor. Okay, there is like input data. There are lock, and this is going to be our alternate function resistors to select what kind of features, what kind of internal peripheral lines you want to select. Okay. They are all are actually going to use it, and you all be proficient, probably get proficient by the end of this course. Okay, and I really want some feedbacks. I'm really getting tired. Okay, I'm really getting starved because of you not giving me any response. Please, great session. Okay, please, can somebody give me like a voice response? Okay, Marcos. Yes,
It was good.
was
Hello,
good.
Rishikesh. I was
Yes.
doing some work. Sorry, I couldn't see that. I was seeing that Proteus.
Hmm.
Okay. So, do you have any idea or something how to know that which package or component is meant for simulation? Because there are
Okay.
so many package and components. So,
Okay.
do you have any idea? Or if there is no component like package component in Proteus, because I'm not very much used to Proteus.
Hmm. So what simulation
So do
software
you
do
have
you
any
use,
idea?
Tina?
Yes.
What simulation software do you use? Tina, maybe Rhyme, which one do you use?
Yeah, see, generally I use PCB designing for KiCad and this Eagle. Okay.
Okay.
Mm, for simulation, sometimes I use Proteus, but not very used to Proteus. Um, what
Actually,
software I
to
use?
find out you have like simulation, what we call it, like a digital clones. We like to call like a more right word is digital clones. To find that you have digital clone, there is like no easy task to find it. You simply open your software and find out
Exactly.
that you do you have it or not. But
Okay,
when we all
we have to check it once,
manually,
one by one.
manually, that
Manually. There is no
manually.
any such hints or something to find it which software.
Actually they don't provide such listing. Actually, Proteus don't provide any such listing
In
that
crack version, I think they
yes,
provide in professional or some sort of.
hmm. Actually,
Mhm,
even in their professional version, they don't have like such a big library of simulated software.
mhm.
If you like
Exactly.
want to like extremely large simulation libraries, you actually have to go for like
Mhm,
Tina. And truly
mhm.
speaking, Tina is like a super cheap. Okay, you can
Okay.
get like a lifetime version for a certain Tina version for like 5 to 6 thousand rupees. I'm talking about rupees, Indian rupees. Okay, 5 6 thousand rupees for
Uh,
personal use.
but Proteus is very, I think, easy and hands-on.
Yes, Proteus
It's
is
easy for
hands-on.
everyone.
Yeah, but
There is reach in libraries. Some libraries are not there. Might be.
yeah, but
Like,
it
do you
its
have any
licensing
idea how
cost is
to?
like 1 lakh rupees. Yeah,
Exactly.
that 1 lakh rupees
More
is
than
like
that.
prohibitively expensive for every one of us.
Mm,
We
Yes,
just
yes,
can't go there.
exactly.
I can simply immediately pay for like Tina's 5,000 rupees for that lifetime license for that certain version. Okay,
Mhm.
they give you
So
like
there
what?
is library of each and every controller in Tina. Actually, I have not used in Tina.
Actually it has like largest
LTS
library in the
Spice I
world.
have used mostly. I've used for electronics parts. LTS Spice
Yes.
for simulation.
LT Spice is
Mm,
actually very good
and
for
for
starting, but after which you should start maybe want to like switch to like Q Spice or other far more powerful
Mhm.
Spice software too. Okay, Q
Okay,
Spice
okay.
is like a more better version
Mhm.
than the LT Spice. It can also like help you to like build your parts which is more in digital in format or more complex systems
Okay.
you want to build, or it is even significantly faster than like LT Spice too. And
Mm.
best part is
Which
that
software you used to? Uh, okay.
in terms
Which
of
software you used to design PCB?
design PCB, I mostly use KiCad for designing PCBs. It
Yes.
got like everything,
KiCad
and
is very, it's very user friendly actually,
it
and
is user
very
friendly.
cheap.
Plus, it's free, and the type of
Mhm.
support it actually gives you is like more than
Yeah,
enough for
yeah,
like
exactly.
most of the tasks.
It's a
Okay,
growing like not, nothing I see. So saw any
actually,
software it
if I
growing
truly tell you that I actually donated like a 5,000 rupees to like a Proteus, no, sorry, to KiCad.
KiCad. Yeah.
Yeah, I actually literally
Okay.
donated 5,000 rupees to them.
Actually, one of my friend has donated 10,000 rupees something.
Yeah,
Generally, I have used sometimes only, so couldn't go for donate. But
we should actually
yeah,
donate
definitely
them
we
a
do
little
this.
bit of money of ours
Yes, yes,
when
yes,
if we
exactly.
like
If we
use
are
it for the
using free
commercial
also,
purposes.
yeah, yeah,
We should like donate them because their
yeah,
alternative
yeah,
is like a
exactly.
1 lakh 2 lakh rupees yearly. So
Exactly.
we
Yeah, I
should
will be
like
also think about
donate
that
them
and
something.
then no issue.
And in terms of like
Sure, sure.
a Spice software, mostly use Q Spice because it's far more
Okay.
simpler and more powerful. And it is actually
Mm.
made by the same person who made the LT Spice.
Mhm.
Okay, the same person built the Q
Because
Spice
in
recently.
Porteous, I couldn't found some of the libraries to use like Pico microcontroller have used. Uh,
Pico. Okay.
20.
Few, like Raspberry Pi Pico, no?
Yes, yes, Raspberry Pi Pico.
You simply can't find it there.
Yeah,
But you can find
these
it
are the
on
level you can't
Tina.
find. Okay, it's
Yeah,
available.
yes, it's available in Tina.
All right, so we'll think
But
about it,
its paid
Tina.
version is like 6,000 rupees, Indian rupees.
No, no, no issue. We'll buy
Yeah.
if it is worth, then no it, uh, any hesitation to buy it.
Mm. And it has like lifetime license for that specific
Oh,
version and 1 year of update.
but I am not sure my software will lifetime or not.
At least on your laptop, it will be for like more than enough long.
Yeah, exactly.
Yeah.
No-
Okay.
Nothing is lifetime, bro.
Any
It's
other
every.
questions?
No, I was just asking that question only. And
Okay.
yeah, one more question I have found this in software parts.
Hmm.
Can you go over there?
Which software?
Mhm. This QID you have written. No?
Yes.
So just GPIO ODR register you have made it on above
What? Yeah.
zero hex in
Okay.
hexadecimal. You are making on all the port GPIO pins, right?
Yes. 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 For now, I'm doing it
Mhm.
because in when I'm
Mhm.
running by myself for my own code, I like to use it like this.
Mhm.
So this is more
Okay.
like
And
a
the model you're putting this as output.
yes.
One for output and zero for input, right?
No, no, no. Zero for input, yes. One for output, and three for
Mm.
analog, and sorry, two for analog and three for alternate function. We have
All
two
right.
bits there.
Mhm.
Okay.
Correct.
In future, we are actually
All
going to
right.
write our code like this. So just
Mhm.
like manipulate only the specific bits we wanted. Okay.
Mhm.
But for beginning,
Exactly.
maybe the most of the student won't understand what I am actually doing here,
No,
right?
no, no. That would be fine. Yeah, if we'll go with the simplex, that would be better for
For
everybody.
starting, I am actually planning to go at a simpler way. But as we
Mhm.
like started to
Correct.
progress, I'm actually going to make it like
Exactly.
more like a industrial what we actually truly use it. Okay.
Yeah, yeah.
In
Correct.
future- Okay.
Hopefully, we are going to start so many session over here like
Mm.
PCB designing. Some session somebody will took. So we'll grow this community. So the student
So
will also
we
get
can
benefit
transfer
and
our knowledge to the people who wants it.
exactly.
Yeah.
Um,
अब चौक
all
पे
right.
चिल्लाते रह गए कोई हमारी तरफ देखेगा नहीं
सही बात है.
आना यार
And
what
मतलब ऐसा भी होगा कि हमारा भी नॉलेज इंक्रीज करेगा with when you will
ah,
teach somebody, then your knowledge will also grow with that.
yes
Then you
that's
you
true
will
that's true
correct them. Sometimes you might be wrong. Okay, so when
yeah
you will correct them, you will get the confidence that yes, it's right. So it's training is very good. If somebody is training, uh, most of the people used to take advantage from that,
mm,
like that is paid or something while they're starting. But if you will start from free something to give to somebody and deliver your knowledge, so you will also increase with the confidence, right?
mm.
Sometime, and you are doing tremendous job. So hopefully we'll come with another after the finishing or in mid, we'll try to go with some more
Okay.
session of PCB
Yeah.
designing and
Actually,
other
for
session
next session,
IoTs
I'm
and all.
planning to teach people like Novoton 8051.
Okay, so
Yes. Is there anybody
great.
here familiar with the Novoton microcontroller? Hello,
Yes, sir.
Novoton microcontroller. No,
What,
sir. Okay, it's actually
it's a,
a newer company, Taiwanese company. The
okay, okay.
most biggest selling part of this microcontroller is that they are cheap plus extremely rugged. Okay,
Uh, 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 uh,
I had even seen those 8051 microcontrollers survival. 2000 volt shock, literally 2000
Oh,
volt shock. It has survived it, and not like one or two shots.
mhm.
It continuously, literally taking those
I
shots.
saw some videos. Nordic, some
No, no, not this is no. It is not
microcontroller.
Nordic. It's Novoton. It's a Taiwanese company. Nordic is like a Swedish company maybe.
Okay, okay.
I'm not sure about it,
It's
but
a newly invented.
it's actually quite old. Maybe like a 2018 or this company has launched its first microcontroller.
Okay, okay.
But its microcontrollers are extremely cheap. Like you can get like a 20-pin microcontroller for the cost of 18 rupees. 8051 with like 16 KB of RAM, and you can do like quite a lot of projects and quite a lot of products with that. I actually made my own small project recently. Just let me show you.
Mhm,
Wait a
mhm.
minute, where I
Yeah,
actually
that
put
would be
that.
very helpful.
Okay, I actually made one of my projects with that microcontroller. My own personal product here. A small.
Oh,
Here
that's
you
great.
can see that there is a small microcontroller. It's an
Yes,
water
yes, yes.
microcontroller. It literally costs 18 rupees to make. Literally buy
Oh,
to buy it. Okay.
so what is this?
This
Which
is
device is?
oh actually I'm actually it is not completely my one. With my friend I actually plan to make auto starters for like farming. And to make this
Okay.
entire board I actually right now it's costing like 100 rupees or around 100 rupees. Probably I'm going to
Oh,
reduce the
that's
cost by like
great.
20-30 rupees more. So it will be like
Okay.
costing like
That's very
30.
cheaper actually. So
Actually, it's
this is
but
very
but
good
but
actually.
but the total features in it are like those expensive equipment, like 2-3 thousand rupees equipment. Okay, simply by putting
Yeah,
this
yeah, I can see that.
digital microcontroller, I can put like
Yes.
a current sensor and make like a dry
Mhm.
run protection unit. Okay, safety unit.
Okay,
I can
okay.
made it. It has
So
a
that is
12
very
lead.
good. We can reduce the Chinese market with this type of products for cheaper. We'll buy the
Not only cheap,
microcontroller.
but this part is extremely rugged too.
Uh,
Okay, this is super
okay,
rugged and
okay, okay. I
uh,
haven't used, but I will try. Definitely, I will try it.
yeah.
I will see it.
Actually, the cost of this system maybe dropped to like 90 rupees maybe to producing this
Mhm.
PCB,
Oh,
and the entire production cost of the equipment probably be 400 rupees, including all the power supply, body, and everything.
mhm,
And I'm planning to make this
mhm.
equipment in such a way that it could last like 5 to 6 years. Okay, while
Oh,
using in the
correct.
farm, like in the environment, facing the environment, it should like
Correct.
survive for
Okay,
4, 5, 6 years. I'm planning to pay it like a
correct.
1,000 rupees, and this equipment will be equivalent to those 3,000 or
Mhm.
4,000 rupees equipment. Okay. CS32V003 is like a Chinese and it's a RISC-V microcontroller. Okay, and it's a 8051
Mhm.
Novotron. So
Okay.
both are actually little different. I actually choose it because it's extremely rugged microcontroller, not like those cheap microcontrollers which failed without a cause, without
Atmel
a
family
reason.
has, yeah, Atmel family like,
In
and
terms of Atmel, we are actually getting lot of like counterfeit parts. Okay, it's been like more than
yes,
one
yes.
year. I never touched it. If
Hmm.
somebody tells me that you have to work on 8 mega 32 or some family of 8 mega microcontroller, I simply refuse. Tell them that your microcontrollers are simply failing. I won't even touch them.
Okay, okay.
That kind of
So
problem I was facing.
this device is used for farming, right?
It's
For
a auto starter.
start the pump or something like something. Huh?
It's a motor starter. Okay,
Start the pump
auto
like
motor
motor
starter.
starter.
It's a,
Okay, okay, fine.
okay. Sometimes you see that
So it
sometimes
is based on uh, wireless or
no, it's a standalone device, not a wireless one. Wireless one will
okay, okay.
probably cost a manufacturing cost of like a 700, maybe 900 rupees, and selling price will be like around 2000. Okay,
Okay, okay.
I
Once
have to make
you created the embedded, you can go with the IoT, right? With
yes,
same things, just with the
yeah, but those devices,
little bit
but there is a
changes.
small problem of like a server side problem. My
Okay,
my friends actually building on it, and they are actually a little bit slow at their part. I
okay,
already
okay. So,
previously built my own like IoT device for that, but it was actually working, entirely working, but they won't able to make their server side system properly.
okay, great,
That
great
was a
one.
small problem. Right. Then I actually come up with this equipment. They,
Sure.
yes, maybe I able to earn like 500 rupees per unit. I'm probably able to sell like a 2000 unit a month. So that will be like more than enough for me.
Definitely, definitely. It's a great.
It will be like my first product which I actually build it for like sales. Transitional
Yeah,
product.
it's a looking very portable and we'll
Rugged.
check it after rugged. How you tested that?
I actually
You
have
are
tested it with
quite
like a
sure that it will last long for 5 year or 6 year.
yes, it will be last. Yes, I know that it is going to last simply because by my previous experience, I know that if I choose like parts properly and provided all the safety and
Okay, okay,
and shield it from like environment, there won't be happening
okay.
anything. Simply because this
Okay,
system
so
can literally
which
handle
power
like
supply
2000
do
volt
you have
shock.
used?
Huh?
Okay, power
What?
supply you which power supply do you have used in this?
In terms of our farming, I'm actually going to use a three-phase power supply and I will step down it with the help
Mhm.
of transformer. I already like built a
Okay, okay,
transformer for it. It is going to
okay,
cost me
okay.
like 90 rupees per unit.
Oh, all right.
Yeah. The most expensive part is like this transformer. I actually planned to go for like SMPS one, but I had calculated that
Mhm,
SMPS is going to cost me like 200 rupees for such a reliability
mhm.
for like 3 years, 4 years
All right, all
reliability.
right. Mhm,
So I opted for like this type of transformer. It's a three-phase transformer. The
mhm,
entire power consumption of this thing is maybe like a 60, 70 milliampere, and this transformer is
mhm.
capable of delivering like 200 milliampere. So it is like I
Okay,
can
okay.
like reduce it a little bit more and reduce the cost like maybe 60, 70 rupees.
Mhm.
Yeah.
Miss, one of in our group, one guy, admin,
Hmm.
Mr. Suresh, he is
Hmm.
tremendous, I think, skilled in uh, electronics devices. Like
Hmm.
he has done very big projects, and also he was uh, work for government projects
Hmm.
and circuit designing is he was super. He's
Okay.
skilled in all these things.
Mr.
So
Gaurav.
quite we can. Huh?
Mr. Gaurav, right?
No, no, no. Mr. Suresh.
Mr. Suresh.
He's I think 12 to 15 years experience. He was very senior to us,
Hmm.
but he's my friend and he's admin of that group.
Mr. Suresh,
Learn
right?
embedded. Yeah, yeah.
Yeah, one is
He's
Mr.
admin.
Dinesh.
Learn embedded in IoTs
Yes,
group.
one is like Mr. Dinesh and other ones there is no number here, no name.
Dinesh is also a group admin of global. I was also ex-admin previously, but
Hmm.
somehow I just come out. I will let you know later on. Uh, yeah, it is.
Okay, then maybe everybody is just getting bored
Yes,
here. So just let's
yes,
log out.
yes.
Okay. I will share the all the
Yes.
information and documentation with you. Okay.
Sure, sure.
Okay.
Okay, bro. We'll go.
Bye bye.
We'll work together and definitely we'll make a team
Yes.
and we'll work for the student also for freshers and we'll try to deliver our knowledge so whoever the skilled and they are able to grab they can grab it so
We are going to
we'll
feed
do
the people who are
fulfill
hungry for
with
the
our
knowledge.
professional work. Yes.
We are going to
All
feed the
right.
hungry.
Yeah,
Okay.
yeah,
Goodbye.
might be
Good
the
night.
guys got hungry.
Good night.
Yeah. Also angry and hungry. Why? Okay. Hmm.
हेलो
Okay.
सर।
Yes.
Are
सर
you
क्या आप
getting bored?
शिव शेख को जानते हैं क्या?
Vikas?
किसको?
शिव शेख,
किसको? वेब से
शेख सईद, आपकी
थोड़ा
लिंक्डइन की प्रोफाइल म्यूचुअल में देखा था मैंने।
किसकी बात कर रहे हो आप?
सैफ शेख।
एक बार थोड़ा अच्छे से बोलो ना। आपको समझ में आ रहा है क्या बोल रहा है ये?
सैफ शेख बोला सर मैंने, सैफ शेख। उसको पहचानते हैं क्या? क्योंकि वो भी वहाँ से है, बीबीवाड़ी से, और वो बीएमएड की तैयारी कर रहा है केआईसीटी कॉलेज से।
अच्छा, नहीं एक्चुअली मेरे लिंक्डइन प्रोफाइल में मुझे बहुत सारे कनेक्शंस आते रहते हैं।
वो मुझे आप
मोस्टली मैं,
म्यूचुअल में दिखा इसलिए पूछ।
हाँ हाँ मोस्टली वो,
और वो मेरा सीनियर था कॉलेज में।
अच्छा, नहीं मेरे से बहुत सारे रोज ही आते रहते, बहुत सारे लिंक्डइन के लिए कनेक्शन। तो अगर एम्बेडेड वाला दिखता है तो मैं इमीडिएटली एक्सेप्ट कर लेता हूँ। मार्केटिंग वाला दिखा तो मैं डायरेक्टली इग्नोर मारता हूँ।
करेक्ट।
मार्केटिंग वालों को इग्नोर मारने का, वो बिना मतलब मैसेज कर करके दिमाग खराब करते थे, फालतू में बाद में ब्लॉक करना पड़ता है उन्हें। ठीक है, कोई सवाल है किसी का? एनी क्वेश्चंस, एनी मोर क्वेश्चंस? हेलो सूरज तापसी जी, आपको कुछ समझ में आया कि नहीं? हेलो। ठीक है।
सर आज मुझे कुछ समझ में नहीं आया क्योंकि मेरा वाईफाई डिस्कनेक्ट हो रहा था बीच बीच में।
कोई
मैं
बात नहीं, कोई बात नहीं, तुम्हें वीडियो मिल जाएगा, और
ओके
सवाल
सर
रहे तो
ओके।
फिर नेक्स्ट क्लास में करेंगे।
But guys, I will tell you one thing. See, take it as serious. So this is what you will never get anywhere. You are
यस सर।
not giving the value of this free class, but when you will come to industry, you will get to know if you have given your time and patience over there with effort. So you could be in different level, like what we thought previously when we started. I was started, no, I don't know about microcontroller only. So I was at that time thinking somebody can tell me something, and now you have lot of sources. So utilize it properly and give value to that, and try to ask the question. If he is saying am here to give the answer, so why you are fearing? Just ask the question, don't be hesitate. Okay, this is my personal experience, 6 7 years experience I'm just sharing with you. So just take how much benefit you can get, just take it.
He is telling by
Okay.
the experience itself, okay?
Yes, sir. Yes, sir.
Always ask the question. Don't think that you are the idiot here, okay? If you ask enough idiotic question, you could become the most intelligent person in here, in the entire group or entire room, okay? Just ask enough questions.
Yeah, yeah.
Okay, any more questions? सूरज ताप्त जी,
हेलो।
हाँ बताइए, कुछ सवाल बचे आपके?
नहीं, मैं कुछ थोड़ा थोड़ा समझ पाया हूँ, बिकॉज मैं बहुत ही इनिशियल स्टेज में हूँ अभी।
अच्छा, कोई
ये
बात नहीं, हाथ पकड़ के सिखा देंगे।
थैंक यू, थैंक
यहाँ पे हाथ पकड़ के सिखाने का प्लानिंग है। कुछ लोगों को जिसको काम आता है ना, तो वो क्या करेंगे कि आप लोगों के जो कंप्यूटर्स है ना, उसको रिमोट कंट्रोल से भी कभी कभार हम लोग कंट्रोल करेंगे, ताकि थोड़ा बहुत कोड में आपके चेंजेस कर पाए। ठीक है,
यू। ओके।
ड्यूरिंग लाइक राइटिंग प्रोसेस ये कोशिश करने की कोशिश करेंगे। ज़रूरी नहीं कि हमेशा मैं ही करूँ, हो सकता है हमें से कुछ लोग जो ज़्यादा आगे हो एक दूसरे से, वो भी एक दूसरे के कंप्यूटर्स को टेक ओवर कर सकते हैं बाद में। वो आप लोग एक दूसरे के क्या कहते हैं, अ, पहचान से भरोसे के साथ में दे दीजिएगा कंट्रोल एक दूसरे को। ठीक है, इस तरह से भी हेल्प कर पाएंगे हाथ पकड़ के। ठीक है,
ओके, थैंक यू।
हाँ, चलिए बस। तो चलिए क्लास को बंद करें, कोई सवाल है तो सवाल का जवाब दूंगा, और नहीं है तो फिर क्लास बंद होने वाला है। ठीक है, मेरी दुकान बंद हो जाएगी। तो सवाल बचे? नो क्वेश्चंस? ठीक है, दुकान बंद। चलिए बाय।